let me also, first of all, real quick, hi, I'm Sheila Radke. Nice to meet you. I'm the math manager for our CPS for the district. So I work with grades pre-K all the way to 12, figuring out curriculum, PD, what kinds of things we need as a district for math. I work very closely with the science person, so we're going to do a little bit of science here today too. I've been working very closely with CEEMS and the MSP and UC, working on trying to make sure that the summer program is going to be wonderful. One of the concerns, one of the things we talked about is the Common Core. So I'm also going to present to you today about the Common Core in terms of what are the things that are going to affect your program, what are the things that are aligned, and what is it we're trying to do in our district so that when you're working with our teachers, you know what they're facing as well. If that makes sense, yes.
Sheila, you might want to just spell out CPS for them so they
know.
know.
My goodness, Cincinnati Public Schools.
Yes.
Yes.
Yeah.
I'm an administrator, yes. Remember those in those days? Okay, first of all, real quick, can I just kind of go around the room and kind of get to know who's who, what you're doing, those kinds of things?
Alright, I'm Sam. I just finished my first year graduate program here. Materials engineering. I'm going to be doing my research in nanoparticles in drug delivery, biomedicine sort of.
Wow, you are probably going to study, and I'm probably saying her name wrong, Anissa Ramirez. Have you heard of her at all?
I have not.
Okay, she's a scientist out of Yale, but I know that she was talking about some nano delivery with gold
Yeah.
as a cancer.
Yeah.
Yeah, that was just really fascinating. Oh, how exciting. Yes.
I'm
Sandra Bryan.
an electrical engineer. Fourth year here, just finishing up. I'll be defending my master's this summer, and I'm a PhD candidate, so I'll just go straight on to the research portion.
Great.
I actually was part of GK12 2 years ago. I was working at Hughes High School.
Okay.
Same program, almost exactly. slightly different, but my research is in bringing computer interface.
Isn't it, to me, it's just amazing where we are today and the things that we're talking about. And can you imagine where we're going to be 10 years from now, even 20 years? Oh my gosh, incredible. Thank you very much, Brian.
My name is Ankur, and when I finished my first year in graduate school in chemical engineering, I'm working on accelerated waste bioregulation.
Awesome. So nice to meet you. I mean, again, I'm amazed at the things that we're doing now.
My name is Patricia. I finished my master's in engineering and just completed my first year PhD. And my research is on energy storage nanocomposites for battery, capacitors, fuel cell applications.
Oh, wow. You so need that. Incredible. Thank you. It's just, again, wonderful to meet you. I think I know pretty much everybody else except for I introduced you.
Yes, I'm Whitney Haskins. I'm the one that
You're the one that we've been emailing.
Yes.
Hi, Bob.
Hi,
Nice to
nice
meet you. And you're taping.
I am Debbie.
Great. Hi, Debbie. How you doing again? It's also always wonderful to see yourself on videotape later. And the thing is we tell our teachers that's a really important piece. You know, videotape yourself so you see your mannerisms, so you see the things that you do. So later on, you can all critique that. I did, and I don't know if you had time because it was yesterday evening, I did give you a reading. I don't know if you saw it, just to go get a little familiar with the Common Core website. Any thoughts or any feedback in terms of, if you looked at the home page, what we're trying to do with the Common Core? What was the main gist of what we're trying to do? If anybody had time to look at it. And
Mission statement said, understanding what the students need to learn about it.
true, understanding what the students need to learn in order to
Get a proper understanding of the thing. Something like that.
true.
Yeah. And the teachers, they need to know, the teachers and the parents, they need to know,
Yes, they do.
what the students that they have to learn.
Yes, they do. The teachers and the students need to have a clear understanding of our,
Parents.
yes, the parents as well, the community, all our stakeholders need to be a part of this process, which is one of the reasons why I'm here with you, because you're part of our stakeholders. So that's very key to us. The depth of the Common Core is extremely important, and I'm going to start going into that a little bit. One of the things that I'm excited about with the Common Core is that it is finally an opportunity. NCTM has been making recommendations for years about what we need to do. And our country has followed a certain path, which I'm going to talk about in just a minute. But finally, our country's somewhat united. There's 48 states that have done this, and then there's been a few that have got some questions about it. You've probably heard on the news, there's some questions, and I think sometimes some of these questions also come from ignorance. And when I say ignorance, I mean it with the true definition, lack of understanding, not knowing what it is. I think some people really don't have a real clear understanding of what we're about. So I'm going to be very interested. I'm going to challenge you after I let you know a little bit about what this is about, to think about these states that are wishing to pull out and the states that are staying with it and which side you would be on, why and why. So think about that a little bit. We'll come back to that.
What's
I am.
What's CDM?
I'm sorry.
What's CDM? Expand CDM, you use
CDM or
CTM, you use CDM?
CPS.
CPS
No, no,
is Cincinnati Public Schools.
No, you used, it was,
CCSS, Common Core State
No, no,
like,
Standards.
it was like,
CPM.
National, the
the
national
national,
math council.
yeah.
Oh, I apologize. Thank you. See, gotta know your audience. The national NCTM is the National Council of Mathematics Teachers, and they have been for years making recommendations based on research and data. I mean, the council does a lot of research. As a matter of fact, when we were in the conference in Denver just a couple months ago, a lot of that centered around reading research papers and understanding what's going on with mathematics and our students and teachers and how we present mathematics in our world. Based on the research that we've been looking at for 20 years, a lot of the recommendations that have gone into the Common Core come directly straight from NCTM, and a lot of things that the U.S. Department of Education has funded, Bill Gates Foundation has funded, and a lot of different Huntsville, all these organizations have come together to fund research on what good math practices are. And I'm going to get a little deeper into that, but the point is these recommendations have been swirling around for a while. And it wasn't until the Governors Association, governors, all the states said, why don't we have some transference that goes beyond our state? You know, we get somebody in from this state or that state, they don't know this, they don't know that. You know, it's unclear as to what people are teaching at what grade level. So really, originally, it started around unity and trying to get a little bit of reciprocal education among the states. What they didn't realize is when they started commissioning this group to come together and form the Common Core State Standards, they went much deeper. Not only did they look at what would be unifying, but what would be correct at the right time, you know, just developmentally for kids to learn. What are the major concepts that we need to know, and what are the concepts that build upon each other? Nobody's ever really taken the time. I mean, a lot of researchers have taken the time to look at this, but nobody in education sat down and really said, that's how we're going to build our curriculum. Finally, we're looking at how we build curriculum. So that's a lot of what this is today, and you're going to hear about that. I'm going to touch on the standards a little bit for science, which has just been released. Did you know?
Sorry, mathematics and English language arts, the two.
They are, and I would present language arts, but I'm going to be really honest with you. I can touch on it for you a little bit, but the language arts piece, that's not my strength.
Mathematics.
I'm kind of the math person. I do know the language arts, and I'll tell you a little bit about that. Remind me if I tend to forget, which could very well happen. I'm going to give you the standards books. We printed these for all of our teachers, and I have one extra if anybody needs it. We went ahead and made sure that everybody had a copy, and I'm really just giving it to you to look over at your leisure, you know, later on, because the site that I gave you is identical. That's where this book came from. On that site, there's more information, as you know. But if you notice, when you were looking at the site, there's things, it's broken into critical areas of focus. And again, I'm going to talk about that a little deeper. Critical areas of focus for every grade level. And then what does high school math look like? And then the standards follow below each one of those categories. So it'll be something for you to look at. These are my notes, so you can kind of follow along and take notes as you like. I'll just let you pass that out. And I'm going to go ahead and get started. And look, I drank a whole lot of water while I do this, because I do tend to talk a lot, but please feel free to ask questions along the way. because I want to make sure that you have a clear understanding and understand too the purpose of me being here, which again is to align you to what our teachers are facing when they get in front of their kids and they try to do STEM and they try to take science and math and put it together and do problem solving, although I hear the word problem solving isn't what our engineers really want. Solution finding, creating new understandings. That they like that a lot better. Okay, I don't know if I'm upside down or every which way.
You can see other one. But I think if you press this one. you should-
Aha,
you
thank
should
you very
be able to
much.
Go to the next one, yeah.
Believe it or not, typically I'm very technological. I have been in movement like crazy the last 2 weeks. Today's the last day for kids. Tomorrow's the last day for like our teachers. So it's been just a little nuts this week. All right, the thing I really liked about this, and this is on page 5 of the state standards, is that they are not intended to be new names for the ways of doing old things. One of the big excitement about the Common Core is that we truly are embarking on something very different than we've done before. That's not entirely true of education. A lot of times education just repackages. One of the things that really happens is our vendors repackage. Our vendors go make new textbooks based on the Common Core. Right. And they do old things and rename them. And we've been giving them a lot of pushback and saying, we're not buying it because we know what this new thing is about, and it is new. It is a new way of doing things. Some of the old ways of doing business, and this is really important to think about, is that there was a different topic for every day, and I'm not sure, depending on how old you are, and I'm not going to ask that question, but depending on when your curriculum was developed, and what state you lived in when that, or country even, your curriculum was very different. In the United States, for sure, we covered a variety of things in 1 year, so no mastery was achieved because we went ahead and hit everything. Now, for your top 3% of the population, that was okay, they kept up. But for the rest of the masses, it was not okay. Every topic was treated as equally important. We now know, based on research, that's not the case. Every topic isn't the same importance at specific grades. They all have importance, but they have differing pieces of strength of importance, as you would say, based on the age that these concepts are being presented. Again, we had elementary students that are looking, kindergartners that are looking at probability. Okay, a kindergartner has no more understanding of probability than the man in the moon, which is non-existent that we know of. But they would dip into these, and again, I'm going to show you that piece in a minute too. Again, endless review at every grade. Think about the beginning of the year. What did you spend the first 3 months on? Reviewing what happened the year before. Very little advance and understanding. Again, we saw a lot of non-mastery occurring. And then it just didn't make sense. Illogical, bizarre, definitely no coherence. Again, looking at the old ways, there was a reliance on rote learning. A lot of rote learning. Think about it, very algorithmic. Aversion to repetitious practice. And repetitious practice does have to happen. I'll talk about that in a little bit. And definitely a restriction to very stereotypical problems that everybody got used to doing. So you could do those problems, but you couldn't make that transference and apply it to something else, is what engineers really do. They can apply. Think about it. You can apply what your understandings are to something else. The way we were teaching math, that didn't really happen. We went from something simple like that where I want you to think about this for a minute. If I've got 856, and this is a younger grade, third grade about between second and third, and they have to look at how they label this, it's easy to go, well, this goes first, this goes second, this goes third. What did they learn mathematically about place value? Not a thing. All right, now we're looking at 100th equals how many tenths? In other words, we're making them think about what that is. We're not giving them a solution up front, a possible solution, whether it be a misconception or non-understanding. We're making them think. When you look at this even, and you look at the problem, this is pretty simplistic, and it's pretty confusing if you think about it, to somebody who doesn't understand it or how to do it. That's algorithmic. To a lot more complication and a lot more having to move the variable. we really need to think about why we're doing things to our kids and make sure the rigor is there. And that one has a little bit deeper explanation, but I'm not going to go into that right now. But again, making the connections and making sure that we ask a lot of our kids at every grade level. Our kids are capable of a whole lot more, and I'm going to take this minute real quick to say this. And the comparison is language arts. We expect our kids to be literate, to the point where the state of Ohio has a third grade reading guarantee, and kids will fail if they do not have certain reading understandings by third grade. In our country, illiteracy is not acceptable. And yet, are we accepting illiteracy in math? I believe we are. And we can't let that go on. Yes?
Are those supposed to be teaching, like, are those intended to teach the same thing on the other side?
Same ideas, yes. But this is nicely and neatly laid out. And when we work with our
And you
kids,
see that exact problem 100 times.
100 times. So what does that do for you? You just get, okay, I can do this.
That's all about it.
But when you give me something like that, I'm like, what?
Right.
And this is where we live.
I was, you know, I get it. I still see the top one on the left as having value, just as like identifying indices. If you have like a large number, it's like this is what hundreds are called, but not. in
If
breaking
you
it
understand it. If you understand, see, you're assuming.
Sure, but
You're right. But you are assuming that understanding of what each piece means. And I'm not saying there's no place for this.
Right, okay.
I'm saying that this is where a lot of times teachers stop.
That's not the end point, yeah.
Right. And teachers do this, and we don't know. A better question, and I have another example I should have shown you, but for 856, how many hundreds are in 856?
Right.
How many tens are in
Not just
856?
what's the value. of the
Right, and if you
place.
look at tens, it's 85 tens.
Yeah.
So, again, we need to have that depth of understanding versus, I can answer a question like this because, and I saw this. I saw it this year, and I about fell over. And this is after I gave a PD. You know, that's always, it's all about perception of what you think they've learned, right? But I walked in and a teacher had her old Scott Forsman book up, and I'm not slamming Scott Forsman, that's what they taught. But she had it up, and it had this exact layout over and over and over, the whole page, right? And she's with her kids doing a small group, and she goes, okay, how many hundreds? And the kid would say, how many hundreds? How many tens? How many ones? And they put it in. And then a kid raised her hand and said, I can't see. Can you tell me what you wrote? I'm like, did you even begin to understand that the kids were more interested in writing the answer in the right spot than understanding the concept? And again,
Quite-
that's,
Quite a lot of this may have to allow to make it easy, because you use worksheets and all, and they just fill that. And I think then the kids start developing that is the way everything is done.
Yeah, fill it out.
And it is
We-
not.
and I believe, and I'm glad you said that, because I believe we as teachers and administrators have encouraged that.
Yes.
We answer their questions too quickly with answers that they do not begin to understand or comprehend, right? And we make them fill out all these worksheets, and one of the things that the publisher's criterion, and let me back up real quick since you brought that up, that Achieve, who I'm going to explain in a minute, a big organization that's involved with the Common Core heavily, has put out a publisher's criterion because these vendors are having such a hard time. But one of the things that they were talking about was we need less reliance on textbooks and worksheets. And if I can get that single thing across to my teachers in the next 5 years, I will be in heaven. If I could take every textbook out of the buildings and take every worksheet out of the buildings, I would be in heaven. Because our teachers rely on that. I just sat down yesterday morning working with my team. I have a team I work with of coaches for math. And we were trying to create a framework for what lessons might look like. And they had, for the lesson part, they had one of the bullets said, and you're going to laugh when you hear this, the teacher demonstrating and modeling and giving examples for 10, or not 10, but for 50 to 60 minutes. Now, I understand I'm lecturing you, and I apologize, and I hope there's a lot of feedback goes between, but we know kids don't learn well by 50 or 60 minutes of you explaining, demonstrating, and modeling. They zone out after 5. You're done. And that's at the high school level. At the kindergarten level, I don't even want to go there. You know, you're lucky if you get that 20 seconds in. If you don't have kids, when I say kids, I'm talking, you know, all the way to 30, 40, 50, whatever, doing, then they're not learning. The only way we really learn deeply is when we're doing. Okay, enough of Sheila on her horse. All right. What has happened is student achievement partners got together in an organization called Achieve. Achieve is funded by the Governors Association, Huntsville, Bill Gates, and many organizations, including General Electric. All of these organizations it's a nonprofit, but all of these organizations believe firmly in the standards and how they were written. I actually am one of the people that helped work on the standards for the math. I did the review of the final draft, and then I did the add-ons and some of the changes. And then I've been working on things that go with it for our teachers that will support our teachers. So I understand my bias when I'm talking to you. I feel very strongly about the standards. But when we were trying to present it to the public and to our teachers, to everyone, we were trying to capsulize what is the major thing about this change. What is this change? And we found 3 areas that we feel are major shifts from what we've done in the past. The first one is focus. And why I say that is teachers do not focus strongly on standards now. And they need to. In other words, if you don't have a clear understanding of what the output is of your input, if you don't know what you want your kids to really get out of a lesson or learn, and you're not clear on the end, how can you create the ways to get there? I've had teachers, and I kind of warn you too here, be careful, because even when people are selecting projects and designing ideas, think about where you want to be first, not where you're just going to start. Oh, this sounds like a really fun project. And teachers do that all the time. Oh, I love this idea. You know, I love doing the weather every day, and I love doing calendar math. Now I'm talking way down below. Or I'm really good at slope and functions, but man, we start getting into trigonomic understanding, and I'm like, forget that. All right? They design things based on what they feel strong in. We have to make sure that they're very, very specific, and the standards are very narrow now. There is less. I'm going to talk about that too in a second, but there is a lot less standards. And the reason why there's a lot less standard for every grade right now is so that people focus very clearly on just what we're trying to get accomplished. I'm not saying there isn't some deviation that occurs naturally. We're humans, right? But the point is you should be focusing on what you need to focus on at your grade level and make sure that kids are really mastering what they master right then and there. So focus so that a lot of energy is spent on what we need to spend it on. Again, deeply, we want those foundations. For us, the math piece is important. I know you're looking more at the junior high to high school perspective because of what you're going to be doing, but if my kindergartners and my first graders aren't learning certain concepts right now, they're not going to be ready at high school and junior high. There is not a real, catch up is really hard. Research and data have really shown that 1 year of bad teaching or loss of concepts and understanding can create anywhere from 3 to 5 years of a gap of learning. Think about what that does to our kids when they go to try to graduate or they give up on math. I've had so many kids come to me back when I was a teacher, because I did junior high. I love those kids. I'm as nuts as they are, so it really worked. Oh yeah, love them. But I had so many of them coming to me just like hating math and so afraid of math. And it wasn't because math is bad. It was because math was hard for them because they didn't get the fundamentals. Once they started getting the fundamentals and started having fun with math, it became a different world. But it takes a lot to turn a kid around once they've lost it. Again, we got to move away from this mile wide, inch deep. Phil Darrow coined that phrase. He's one of the writers, and that's what's been on the news a lot. Again, I don't know if you paid attention to that stuff on the news about the Common Core, but that's the problem again with America. We did so many things at once, it was unbelievable. The CEEMS study is a study that was done internationally, tests given to kids all around the world so that we could understand where they stand in terms of understanding and what is being covered. And I'm going to show you a little bit of the results from that in just a minute. The bad news is we rank 27th in the world. Finland is #1. And we had our English language arts manager, went to Finland this year, not me. I plan on going next year or the year after, but anyway, she went to Finland this year and she came back she was just really excited. But there's a reason. It's kind of like senseis from Japan. Education is really considered such a high priority, and also kids are in school for a long time doing this. The Common Core standards were there before we even knew what we called them. They knew certain things. They knew to break it down for kids and make less happen. All right, so teach less, learn more. Again, less topic coverage is actually associated with higher scores, and Singapore has also shown us this. With the CEEMS study, we learned that in A+ countries, these are countries, Bill Schmidt, by the one, is the one that's really worked heavily on the CEEMS study. He's out of Michigan State, if you ever do look up any research on any of this. He found that this is topic coverage. In countries considered A+, Finland, Singapore, and some of the higher achieving countries. If you look in first grade, they cover certain things. Second grade again, third grade, now they're adding. There's a whole lot they don't cover. The kids aren't ready. They're just not ready for this at this point. But then if you look over here, now we're adding topics, but by 6th grade, we lose all that first, second, third grade. What do you think that is in first, second, and third grade that we're teaching them so heavily? Addition and subtraction. We're teaching them the operations. First they got to learn the numbers, counting and cardinality. That happened in kindergarten. But first, second grade, we're getting addition and subtraction down. And then in third grade, we're learning multiplication. So the focus in multiplication leads into fractions. And fractions, just by Leaping Mom, did a study a few years ago, and the American teacher knows less about fractions than you could ever imagine, which is really frightening. Which is one of the reasons why I come to UC and I do the things I do. I want to influence that and really work heavily on that. I think every teacher teaching grade 1 through 8 needs to have a lot heavier math understandings and needs more math courses, definitely. But if you look, we lose certain ideas. Now we're starting to add, by the way, down here, 8th grade, that's when we start getting into some probability and statistics. Kids don't understand all the operations and all the math that goes behind being able to interpret and understand probability and statistics well. As a matter of fact, you're not going to see a lot of, to the detriment of many teachers, money and time down in the lower levels. You do see some touching of time. Not much. Why? Because we're talking decimals, we're talking fractions when we think about how we tell time and when we think about how we do money. And really that occurs more in 5th grade. So now we're making sense. But we did it, because this is America. Before the Common Core. Right here, there she is. You know, everything. Hey, we even have probability and stats in first grade.
Set theory and all were taught, introduced in 1990s into grades 2 and 3. It was mind-boggling.
Amazing.
See, without fractions, how can you even comprehend set theory? Because you're always talking of parts of things. Very abstract. And so they learn superfluous knowledge.
And math may come easy to you where you are now, or even in way when you were young, and that might have put you where you are now, which we want more people to be able to come where you are now. And math came easy for me. However, most people didn't either have the high intellect to really understand it and grasp it the way we were doing it, which is this output, which is crazy. We needed our kids to have firm foundations. And now that, based on the CEEMS study, that's how the standards were derived. The CEEMS study, and again, all the research that went into it. Again, the traditional approach, and the reason why I show this slide, is this is literally a slide that Bill Schmidt shows, which is really funny, that is our vendors. Here's our textbooks. From K-12 continuum. We've got number and operations all the way through. We've got measurement, geometry, algebra, and functions, and statistics and probability. Think about the textbooks. Think about the companies. Isn't that easy for them? Easy. Don't get me wrong, they do hire some retired teachers or teachers that are no longer teaching to also work on it, but a lot of times that's not who's working on textbooks, which is scary. So here they are, you know, I'm just going to extend a little bit of what I did in grade 2, extend a little, or it's a piece of cake. That's the easy, and that's the current textbooks that everybody has right now. And I have been fighting tooth and nail with vendors lately. I think I've become a possible curse word on most of their list. Although they're all working with me heavily because we're a multi-million-dollar deal. So I get courted by them like no other. But I think they're bringing their authors in to me now. Because I sit down with them and I say, this isn't gonna fly, this is not Common Core. You added this, you added that. And they're like, okay, Sheila. All right.
Excuse me,
Yes.
didn't all schools use same textbook from same publisher?
Actually, no, but I'm going to tell you the differences are so minute between publishers, it's unbelievable. Now, there are a few select programs that I think are better than others and have literally been that way all along. There's one group called Investigations, which is more of an inquiry approach in learning math. But again, they don't have their concepts in the right locations. They don't have the right developmental pieces. So that was the discussion I've been having with them. And actually, Investigations has been around for about 10, 15 years. They have the new 2013 Common Core, which I've already got all posted, noted, and marked for them on the changes I want them to make. So again, they're not there yet, but they're getting there. We also had Connected Math for high school math CMP. Some of these programs are starting to get with it, and some of them were listening to the writers because people like Steve Linewan, who is somebody who's been involved with testing and math understandings for years. He does our GE audit, he speaks at all our conferences. He's very, very smart, and he's really worked with the TIM study as well. But Steve works, everybody knows everybody up there in the academia land. But anyway, he is now an author on one of the books. So, I mean, they're starting, some of our best researchers, Deborah Ball, Phil Darrow, who wrote the Common Core, he's one of the main 3 writers. They're all starting to get involved, but it's not moving fast enough. And why do I say it's not moving fast enough? And let me digress for a second, or get away from this for 2 seconds. We have a state test coming up. Right now, we've been taking, this, all the states have their own state test. We call it OAA now. Before, we called it proficiency. I forget what we called it before that, but it's always, okay. And the state test covers all these ideas. Well, the Governors Association got together and said, oh no, you're going to have, if you've got a new curriculum, you need to develop a new test. So there's 2 consortiums. There's PARC, Partners for Achievement for College and Career Readiness. I think I said that right. And Smarter Balance. And depending on, about half the country does one, half the country does the other. When you look at PARC, the test items are very different, and I'm going to talk about that in a little bit. But the reason why I bring that up is because, once again, we're going to begin testing, but now we're testing based on what kids really need to show us they know. Is multiple choice a way to show us what we know? Most tests now are multiple choice. What does that tell you? Does that tell you true knowledge? Think about it. Even SAT, CT. But that's okay. One of the Common Core writers is now the president of the SAT, and he's going to, everything's changing. It's really good. I'm very excited about it. All right, Common Core. What we've done now, if you'll notice in grades kindergarten and first grade, we're looking at number and operations, like you said, which is adding and subtracting. And again, operations and algebraic thinking, same thing. But again, we're in base 10. And the difference between number and operations is understanding numbers, filling in the operations. And when you think about algebraic thinking, it's not algebra like you think about it, but we do need them to understand that 10 plus a number equals 12. We want to start them that low on that idea. And think about it. A kid goes and he says, and you say, how many fingers am I holding up? They might say, okay, I got 7 fingers up right now. And if you say, well, how many more fingers do I need to hold up to get there? They don't know. Okay, so we've got to give them some ways of understanding this. Other than them holding this up, which is an easy fix when you're doing it on your hands, which you don't want them to stay there forever, we've got to teach them some ideas on getting around that. So those kinds of thinkings do come down to these grade levels. However, it doesn't turn into expressions and equations the way you think of it. A plus B equals whatever, or A squared, all those. It doesn't turn into that until they're ready in 6th grade. We're showing them all kinds of ways, mostly concretely manipulative ways, before that, so they have that firm foundation. Number and operations, you don't see that over here because we're using it over here. All these things are finished. We're not reviewing them anymore because we're there. And each one of these have something we call progressions. And what that means is in first grade and second grade, or kindergarten and first grade, the second grade, we're adding and subtracting, and beginning to group in second grade. Third grade, we're multiplying. Fourth grade, ooh, we are starting to divide. We're bringing in fractions and understandings here. Now we're bringing it in even deeper, multiplication and division of fractions and mixed numerals. Whoa, fifth grade, we brought in decimals. Boom, now we're ready to start not teaching money, not teaching time, using it. Because these are things that are expressed in decimals, they're also expressed in fractions. So now we start using it. Now we're exploring the number system of irrational numbers, rational numbers, squares, all these things, and using expressions and equations because they're ready. We're not bringing it down here. Now they're ready. So now we're doing this, and that leads to readiness for high school. And if the kids don't have this firm foundation right here, they can't do it here. And that's what we've learned. Cincinnati Public, 63% of our kids fail algebra. Don't worry, that's my big thing. I'm really working on it. That's like my number one focus. If I want to be employed for the rest of my life. Algebra 2 is the next big one. The only problem with algebra, and I'm going to come to your question, and I can only say this really quickly, and please don't think I sound smug. Algebra is a piece of cake. I'm thinking you're probably thinking so too. But it can't be a piece of cake if you don't have a firm understanding of how to manipulate numbers. And you don't understand all the rules that go with it.
So if you're not getting, this is more like practical usage. If you're not getting to time and numbers until 4th, 5th grade, is there any or time and money, is there any practical reason to get to it earlier? So in 1st, 2nd grade, kids need to have an understanding of time, but they're not getting until 4th and 5th. Do you find any practical life reasons to get to it earlier versus the progression?
Two good questions, or two good answers for that same question. One, and I loved it when Jason Zemba, who is the number one, he's the main writer of the math. He's the lead on the math. And Jason's a physicist. He's not a mathematician, he's a physicist. I love it. And sometimes he carries me away, which is really fun. We'll get into a conversation, then all of a sudden he goes, and I'm like, okay, well, I had you here. But one of the things that he said is, and you're going to find that financial literacy in high school has moved to economics. Economics is a social studies curriculum. Now, part of why I'm saying this is there's also some cross-curricular understandings that have to happen. If you can understand some numbers, then the financial literacy piece goes into economics because economics is the study of numbers and social implications. Think about it. So there's some cross-curricular. That's why it's so important that we have science and math and all the different integration that we are having when we work on STEM projects. You know what STEM is? Science, technology, education. Okay, just making sure. Okay, that's why this integration piece is so huge. So what Jason says, and he cracks me up, is that, parents should be talking about money and time with their kids. The only issue that we have in an urban setting is their parents don't understand time or money. Let me tell you. And that's a huge issue. Very huge issue. I can't tell you how many times I had to help parents figure out some things. So that is a big issue. But so knowing that in the Common Core, what we wrote into in here, number and operations, there's some pieces that are called supporting pieces. And there is a place, and you'll see it, and I can't remember now, I think it's 2nd grade that we put this in, where you have to know your coins. But we don't teach them 0.25 as a quarter. We teach them at 25 cents as a quarter. We don't really talk about the notation that goes with it then. We really don't, because kids don't normally see notation. They want to know how much in that grade. And that's the whole thing. We want to teach them how much. So they're learning the values of coins. And then what we've told our teachers to do, and we've written it into the Common Core, is use that as counting. Count by 25s. Count by 10s. count by 20. I mean, you're getting to a point now where we're using it the way we should be using it to bring that foundational learning even stronger mastery of understanding how numbers work together. So we teach them coins. We do. There is a practical reason. They need to know. And after a while, they make certain associations because, again, the thing is we want learning to transcend. We want it to move over. We want it to be able to go to the next place. And if they have that firm foundation, they can take it there. You know, I can't tell you how many kids raise their hand and go, if I've got 10 dimes, I have a whole dollar. You know? And they figure that out. They figure it out based on molds and models that we use. They figure it out because somebody's told them and they've remembered it. But these are social situations along with understanding numbers. Does that make sense? Okay. Time's the same way. We do teach them the clock for like a little while. It's a supporting factor. We do teach them to tell time on the, you know, like every 15 minutes, those kinds of things. But when you start talking half an hour, now I'm getting into third grade. What does half really mean? Don't get me wrong. We want them to be talking these things and get some understandings, but they don't have any understanding what that is until we really start talking about what does a half mean. And if you don't understand multiplication and additive reasoning, you can't understand what a fraction is. The biggest problem we have, I'm trying to think, Bob Laird and a bunch of people, I'm trying to think who all, I think Steve Leinwan and I know for sure Bill Schmidt's been working on parts of it, but not like Bob has. They did a whole study. I mean, Levy Ma started it, but then Bob's been doing a whole study called OGAP, and he's been working with the Ohio Department of Education, not the Ohio, the U.S. Department. He just got a second grant, and Bill Gates Foundation, because the study, 7th grade, most kids don't know their fractions in 7th grade. Now, if they don't know how to manipulate fractions correctly, and we're going to expressions and equations, how can they do that? How can they do that? You can't make that leap to algebra without fractions. You just can't.
One thing may be nice for the fellows to know, this whole theory, the way it's organized, learning, has one big advantage is, and people have done research and found, that this, if they master the basics, with that first column is basically, and many of the good ones may themselves get an idea of fractions by discovery.
Yes.
Okay? Like 30 minutes is half of the full hour or something. You're not telling them that, but you're saying that 60 minutes and then 30 minutes, they may that is what you want to occur by the time you're talking about fraction. Then they'll grasp it so much faster.
And again, that's that whole idea of mastery at a younger level leading to that transference of understanding. And I tell you, one way we know that this is really true is the NEEP tests that are there again. These are tests that are more national than our Ohio OAA, and a little bit more telling. But they did studies, and they did studies specifically in Massachusetts. And they went to Common Core before Common Core almost. They started weeding out subjects, and they found that kids were able to solve problems they had never seen before because they had the foundation. There are certain things they didn't cover. And there's another presentation I give, I wish I'd added that slide now, of Singapore math. Because Singapore, you know, they cover 40% of what's on their test. And the kids score, what, they're third in the world. They cover 40% per year. Amazing. They make that transfer. Because once you have that foundation, you can start figuring some of this stuff out. All right. Just so you know, there are focus areas of what we're doing in every grade level. I've kind of given it to you. K2 addition and subtraction, we are starting problem or some place value, because that's an important piece that they've got to understand to move into multiplication and division. And then the beginning of fractions. And when I say fractions in third grade, they're talking equivalents. How do I know the same fractions? They don't really start manipulating fractions a lot until they get to 4th grade, and then in 5th grade they're manipulating them heavily, so that in 6th grade we are ready for ratios of proportional thinking. And think about most algebra, that's exactly what we're doing. I mean, that's what it's all about. So we start a little bit of those early expressions and equations only because we're doing ratios and proportions, but in 7th grade we're using it, we're reasoning it, And we are really doing the arithmetic, meaning all the operations and all the properties that go with it, of rational numbers. Because in 8th grade, now we're getting into irrational numbers, linear algebra, and linear functions. And that's real important. By the way, this is the beginning of algebra. So a lot of schools, including CPS, and I'll let you know how it goes through your professors, we're going to 8th grade algebra next year because they're so similar. Now, I'm not 100% sure, and I'll be honest and say this to you, see, I'm worried because we have kids that don't do 7th grade really well. So what I've done is I've created a class to support them with what? These kinds of things. So they're taking 2 classes of math next year when they take algebra. They're taking something I call Encore, because I didn't want to call it intervention. It's Encore. So they're taking that class, and it's going to shore them up while they're doing algebra. So, there we go.
Is that so that people who, the 64% who fail have 2 chances at algebra?
Correct.
Okay.
That's exactly why.
Yeah.
Very perceptive, good transference of knowledge.
So you're not going to geometry first year of?
We are not. And part of the reason we're not going to geometry, to be really honest with you, is there's pieces in geometry that I feel that if they have algebraic understandings first, they're going to do better. They're going to do better. Because our geometry has some trigonometric functions. You know? And if you don't understand functions, we're in trouble.
So then 12th grade, you have them taking what, pre-cal or trig?
12th grade's interesting. 12th grade this year, okay, first of all, the Common Core does cover all the grades. But what it says you have to have, and what the state of Ohio has decided, is you have to have Algebra 1, Algebra 2, Geometry, and an Algebra 2 equivalent or higher course for 4th year. Because why? Because we used to offer stuff like consumer math, math to have fun with, math to go to Kings Island with. I mean, we didn't really have standards that govern 4th year math. Well, really, how helpful is that? Now, don't get me wrong, we also offered AP, calculus, pre-calc, calc IAB, blah, blah, blah. Okay, and this is all good for our kids that are in that top tier. But what we basically said to our kids that basically hardly made it out of Algebra 2 or they already dropped out, right? That we'll give you a course to have fun with in the 3rd year, and that is not what we want to do for college and career readiness, because what we found out, state of Ohio and many states and many colleges and universities, is that our children are going to college then, if they make it into college, and they're taking all these remedial courses that don't count. And what do? They drop out too. I knew the percentage and I forget now.
Close to 50%.
Close to 50% drop out if they have to take remedial math in college to get ready for college algebra. So that's huge. I think I knew now, but that's all. Just kidding. But the point, it's a lot. It's a lot. To the point where there's been laws made in the state of Ohio now that universities can only offer so many remedial, like a certain percentage.
Yeah, UC
And
cannot
that's-
offer any.
Well, yeah, you go to Ray's Place.
You have to go to
Or-
the,
Yeah.
Yeah, you go to a junior college, but even the junior colleges are getting hit.
yeah.
You can only offer so many. And I've been working very closely with the college board, and Joe Gilko comes down a lot, and we work on AP courses and offerings, and we've created 4th year courses. So our 4th year courses, now they have matter. And if you look at the Common Core later on, you'll look at some of the things that are required out of high school, standards come directly out of that. In other words, this is no longer a 4th year option for somebody to take math to just have fun. They have to get in there, and it has to build. It has to be at least equivalent to Algebra 2, which most of our kids have trouble with, and it has to build from there. So to be honest with you, the 4th year course that I have this year is coming out of Athens, I'm sorry, Ohio University, and Greg Foley and a group of people worked on the curriculum, and we've been trying it out. This is and as a matter of fact, I'm part of a big study. CPS is going to be part of a big study, so we're getting a whole lot of it paid for by free. But it offers statistics and courses that they would be getting ready, and that's another thing. Our writers don't believe that heavy statistics should be taught to college. They feel like you better have some really good understandings of all the math that you need to get ready to be able to apply it and use it in a statistics course in college. Because if you don't already have all those understandings, you need to spend real time on understanding what true statistics even means and how to interpret the data, much less be able to create it. So they feel like that really shouldn't even be taught to college level. Don't get me wrong, we've got bivariate data, we've got all kinds of data. in the Common Core, but it is not the major focus of the grade levels. So saying, do we offer stats and prob in fourth year math? We do. But that's for our advanced kids. Now in my AQR course, which is Advanced Quantitative Reasoning, is what the name of this fourth year course for average students, it kind of takes them back all the way here, first quarter. So we do one last time of review, and we try to build them. The whole first quarter, we're doing some of this stuff. Then we're moving into algebra, and we're moving into algebra 2. Then we're taking through some stats and prob ideas, and we're taking them through some trig. And the reason why we do that is to make sure that they're ready for the test. So when they take their placement test, they're fresh with everything we think are on the placement test. And they should know it and master it. So that's our hope. Again, study, I'll let you know how that turns out. But that's what a lot of schools are starting to do. They're creating a course like that. Our other kids, I mean, I don't know, you don't have to show me your hands, but a lot of you probably took calc. A lot of you were going and moving on, you know, so, but we have a lot of kids that can't do that. Why, I don't know. Calc is algebra with a twist. I love it. But anyway, okay, so obviously math is, coherence is a second shift. And what I mean by coherence, I've just shown you to a certain extent. There is a coherent thinking that goes behind this. In other words, it's a building piece and you can trace it. If you go to some of the exercises I do with my teachers, we're actually tracing it. And as we trace the actual piece, like we'll look in the very beginning and we'll say, okay, I've got to do cardinality first. I have to know how to count. I have to know what a number means. Then I go into addition and subtraction. Then I go into multiplication. Then I go into fractions, rates and proportions. You see that piece. You see how multiplication is extended through the fractions piece. You see where the trajectories are and why they start as low as they do and build up, again, from research. Again, the other piece that we need to do is look at how do we build this conceptual understanding. And that's why the coherence piece was so important when we wrote the core. What is the previous learning? How is it sequential? Where are we going? And this is really important because this fractional piece, which is a foundation for algebra, is key. And a lot of what we do in the younger grades is building us up so that we can manipulate these numbers and understand this piece. And again, that's, again, the National Mathematics Advisory Panel, that's one of their reports. NCTM has been saying it for years. Finally, we're getting there. 2008, and we are just implementing the Common Core 100% this year. Took too long. Trajectories. This is just a good example. Fourth grade multiplication of a proper or improper. Here we're multiplying proper and improper fractions. Now mixed numbers and whole numbers divided by, or multiplied by proper fractions, improper. Divide fractions by whole. You see that progression. So from here to here. Now up here we're dividing proper fractions by proper fractions. Now we're getting to the meat of it. And then in 7th grade we're using it. Again, another example of the staircase. This is just algebraic thinking in 1st grade. Moving to this is addition and subtraction. Here we are now, we're multiplying. Now we're starting to look at the beginning of how we're writing simple expressions and how you have to put the operations together. Now this is where commutative property, distributive property, etc. starts to come into play. And then how we really look at expressions and equations, the real thing. So again, just another piece. All right, data representation. Again, here's an example of a standard in 3rd grade that has something to do with data, but look at what we're doing. We are pulling some things together because there are some coherent pieces within grade levels, and when they talk about coherence at a grade level, they're talking about how do they work together. Kids should be able to draw a picture graph and a scaled bar graph to be able to show a data set. Now that's not true data and probability. It's, again, there's like one little touch on it. It's a supporting factor because what they're really doing is solving 1 and 2 step, how many more, how many less problems using these graphs. Again, they're using pictorials to be able to see how do I do this. But they also have to be able to draw it because kids learn better if I just show you, you did not learn a thing. Maybe this much. But if I make you do it, then you're learning. So that's where we do that and how we tie it together. All right, geometric measurement. One of the things that we did with geometry is we are trying to show in the real world, if you think about it, the whole world is geometry. Okay, hello, I'm preaching to the choir. But our kids weren't making good relationships. They didn't even see the area model with multiplication. What a perfect example to show them in the beginning. So from early grades now, they have to be drawing and showing models of area to be able to get to multiplication and addition. And of course, you can imagine different focus. I mean, especially when we get to the Pythagorean theorem, how important that is. And we can start showing why the Pythagorean theorem works. So we show the area model, and we show the squares that go with it and how they equal each other up. All of a sudden, that light bulb goes on. So these are the pieces that people weren't doing consistently because nobody took the time to tie it together. Now we're starting to realize, just as you are in the presentations that you guys are going to be working on with your teachers this summer, how it's so important to start putting these pieces together and make them work together. All right. The last one, again, is rigor. So the 3 shifts are focus, coherence, and now rigor. Rigor is an interesting one, and I just got to talk about this real briefly. Rigor in the true meaning of rigor, because teachers still teach what they think their kids should be learning right then and there. And teachers underestimate their kids every day. So they teach these simplistic things, or it's because the teacher doesn't have the knowledge. And then the kids are not achieving to the level they could. I believe very firmly, as do many researchers, set the bar high. If you set the bar high, you're going to climb a lot higher. You're going to try to reach that bar. What we really talk about is this balance of solid conceptual understanding, and I'm going to tell you right now, that is the #1 thing we lack in our country. Our country does not have a good conceptual understanding of math. They don't really see how this all works together. Procedural skill and fluency, that's already being done. Procedure, how do I do this? What does it look like? Which we hope kids learn through an inquiry approach. We don't want to just give them the procedure. And fluency doesn't really mean what you think it means. Yes, we do want to be fluent in mathematics in terms of multiplication facts. We want them to know them. And I'll show you a fluency chart. But 8 out of 10 teachers will tell me, well, that means I need to give them a time test and they just need to know their facts. Okay, rote memorization is not the key to life. I mean, yes, I do want them to know them with quick recall. But unless you use it all the time, even you might stop for a minute at 8 times 7. You know, you've got to get 56, by the way. Okay, yeah, just making sure, check. All right, but the point is, we need to make sure that they understand, when we talk about fluent, that they can manipulate them and understand them. When we're talking about fluency, is we want them to be able to see the connections and how they work. Yeah, we do want them to understand that 8 times 7 is 56 and have a quick recall, but that's not just the fluency we're talking about, and we'll show you that later. Procedural skill is your typical algorithmic stuff, and then of course the third piece, which is very important, is the application and that transference. If I can't tell you how many kids now, last year I went into a terrific fight last year with my district because the state did something really cruel. They said that everything that was going to be covered on the test, that if we went Common Core, we'd be good, just to add in more data and probability. So we did that, and then the state came back out and issued a letter to all the principals at the beginning of the school year, after we had written the pacing guide. It said, oh no, you also need to cover all these things as well. And I'm like, are you kidding me? So our teachers totally rebelled, and our principals, and I don't blame them, when their evaluations are tied to test scores, okay? And they said, we're going to go back to teaching the test. And you know how they do that, teach a test? They get the test out, the old test items, and they teach them. Okay, is that application of skills? No, they're learning how to do one test item, and we don't see transference. No wonder our scores are as low as they are. And I fought that for a long time. I'm finally winning. All right, solid conceptual understanding. I think I've kind of gone over that. I'm not really going to get into that again, but it's again teaching more how to get the answer and giving kids an opportunity to learn how to do that. That means that they got to do the work. You know, I'm not going to get real deep into that because I think you understand that already. The fluency, again, is speed and accuracy, definitely, but it's also being able to understand, they've got to be able to practice these core functions over and over again. To understand, repetition is good. You shouldn't have an aversion to repetition. If you're not doing homework and you're not doing things to continually practice them, but it doesn't mean that it's just simply giving them a set of multiplication tables. Maybe they have a whole lot of problems that involve multiplying in them. Word problems. Doesn't need to just be these mathematical equations. All right, here are the fluencies. We do expect, and I have told my teachers, at each grade level, they need to be able to do this well. If you'll notice, yeah, I did add it in. There are a couple from memory. So second grade, they do need to know how to add and subtract from memory, all the way up to 20, and multiplying and dividing single digit up to 100 by third grade. Everything else is being able to do it and do it well. That's all we're saying when we say fluencies. But that, and you have that in your notes, that's what every grade level is expected to do. Notice it stops at grade 6. There's a reason. Now you've got your arithmetic fluencies down. Now you're starting algebra. All right. Again, application, I'm not going to get into that too much because I think you understand application, you're engineers. It's about being able to apply to the real world. Use what you know. Here's an example real quick, kind of cracks me up. This one is Phil Darrow, shows this a lot. A lot of times of teaching in the past is we show kids all this crisscross method of how to do fractions and everything else. That is a bunch of junk. You ought to see him do it. It is funnier than heck when he does it because the whole audience is laughing and he goes nuts when he's doing it. But they don't get a good understanding of what is 3/4, what is 1/3. They don't understand where that trajectory even is on the number line. They don't know where it's placed. They don't know what it means. What do you do when you have unlike denominators? And before you get to the algorithm of find equivalence and when the denominators change the whole fraction, which is the final way of doing it, they have to understand some physical representations of that to see how they do fit. And what is your factor? Now we're getting back into that whole multiplication piece. And how did you find that common factor to turn them into equivalents? And to make sure you can understand now you're doing the same thing so that you can add them together, multiply, and whatever you need to do. Well, multiplication, you don't have to do that. All right. Example of the OAA. Now, some teachers would like to tell me that if the kid picks A, it's just they don't understand. They're thinking that, since there's a 3 and a 6, it might be that. 3 nights, 4, 6. They get into this whole explanation to me, and I'm like, okay, you guys, really? They picked whatever number they picked because they guessed 90% of the time. This doesn't tell me what they don't know, and tests should tell us what kids don't know. Because then we need to help them learn it.
Is that a real math?
That's a
like,
real, that's off,
fifth grade math?
that's right. By the way, where is equivalence of fractions? 5th grade math. If we're not working on equivalence in 3rd grade. So again, we've made it foundational, but the rigor is very different. Fractions are in 3rd grade. Equivalence of fractions is the whole second half of the year. Is in 3rd grade now. It's not in 5th grade. But because we did all this other stuff, it had to be in 5th grade. How could they begin to understand it? We were doing all this other stuff. They had no real multiplication understanding. They can't do fractions. But now but that is a real test item. That's a real thing. One of the released items. I'm not breaking them along. I can't show you the real OAA. But they release items all the time, and that's an exact item. Here's what we expect for a performance task for a 5th grader now. Again, the question is, Tito and Lewis stuff with pizza. Tito eats so much, the other one eats another much. Lewis eats this much. Then Lewis eats the other half. Okay, so you get the idea they're eating bits and pieces out of the pizza, right? Tito says he ate more because Lewis did not eat any pepperoni. Lewis says they each ate the same amount. Who is correct? We give them a problem. Show all your mathematical thinking. That's life. That's the real thing with math. That other piece, that whole multiple choice thing, that's the answer we kind of expect to see. Look what he did. I mean, he gives you, I will look to find who's correct, Tito or Lewis, I'll make a diagram. Now, obviously, somebody's probably coached him a little bit in this, but these are the pieces we expect. He shows. What did he do? He says some diagramming. We call that modeling. They come up with it, then he gives his answer. And he explains himself. That's the kind of thinking we want to see, and that's what Park is doing. Park is going to have a lot of these types of questions. Park is also going to have questions like this. And I don't think I showed this. Let me see. No. I'm going to go back to this one real quick. One of the questions on Park might be, which fraction is equivalent to 1? Name 3 fractions equivalent to 1/3. And there's going to be, the one I saw in the prototype, blocks. and the kids have to put in their numbers. Now, it is true, they could still just guess any numbers, we get that. But at least we're not
The
giving them this
chances are,
ABCD
I
thing.
think, yes.
And if a kid gets it right, we know he really probably has it.
Yeah.
Okay, the likelihood, probability, of him getting it right, not knowing it, is a lot less. We can also tell by the test what answers he puts in there, unless he's just totally guessing, what part he doesn't understand. You know? All right. Again, focusing the major work, and this particular slide speaks to the fact that we have told our teachers every grade level has a major work. Like I told you, kindergarten and first grade, well, kindergarten's counting and cardinality, beginning, adding, and then we've got first grade is adding and subtraction. You better be working on that. There's a few other standards in there that you can work on, a few, but the major work of that grade, you should every single day be doing something with that addition and subtraction. And you should be doing it for a while. All right, mathematical practices are a part of the standards, and this is going to lead me into science, because science has something similar. The core writers felt like they weren't finished. And they said, okay, we've given you some outcomes. Kids should be able to add and subtract. Kids should be able to do this. You know, they gave you the output. What are the expectations that we expect kids to do? But what they didn't say is how are they going to do it? And here's the how. We need kids to make sense of a problem, be able to break it apart and know what to do with it. And persevere. That word persevere is very important. In this day and age, and this is why this whole CEEMS approach is very important to us, because we're hoping you're really working with our high school teachers who learn a lot of algorithmic ways and do a lot of algorithmic type things. And we know that science and math can't really be that way, not really. This is really important because our younger kids don't persevere, they give up. And what does the teacher do? Let me tell you the answer, let me show you again how to do it. That's not teaching them how to do it. I mean, you've got to fall down, you've got to make your mistakes. I mean, yes, there are times teachers have to do some direct tutoring or instruction for this. But for the most part, there are many ways to teach mathematical concepts that correlate to real-world problems in a way that kids can find their way. And that we know already from doing all this understanding of brains and brain function is how kids really learn. So it's the same thing here, but they don't persevere because for years we're like, okay, let me give you the answer. I got 30 kids. We're going to move on here. You can't do that. Kids have to reason abstractly and quantitatively. They've got to get there. They can't do concrete forever. So this is important. There is a place where, okay, you've got to figure this out quantitatively, even if we're doing it, you know, with models. But there is a point which I got to think it. It has to get, and you know that, or you never get anywhere. Construct viable arguments and critique the reasoning of others. Most kids can't tell you why they did something. That becomes really important when you're trying to talk to somebody about your engineering project or defend your master's, defend your PhD, your dissertation. You have to be able to explain the why and what you saw and where you're going, and that starts young. So when we think about these, everything we're doing here, we're getting kids college and career ready. That is the focus. We want our kids to succeed. We don't want to be 27th in the world anymore. We don't want to hire our engineers at GE. I saw a big thing with GE. I just came back from Orlando. I'm going back down in the summer, but I work with GE, and that's where we all meet sometimes. Actually, I'm meeting in New Jersey next week, but the point is, GE is one of our biggest benefactors, and they are very much part of the benefactors of the Common Core as well. And GE says, you know what? We get all these engineering applicants, and maybe one might fit, or I might have to go out of the country and get somebody for that particular position. That's scary when a local producer can't find engineers. That's really scary. And they said that at Evendale. So I'm like, oh. Now good news is my son-in-law works for GE. He's an engineer. And of course my father was very involved in the Stealth project for years with GE. So love GE, but the point is we got to be able to hire our engineers locally. So getting back to this, model with mathematics. If your kids can't model and show you concrete examples of math, then they probably don't really understand it. Some do. There's that percentage, okay? Don't forget, we're always talking kind of that bell-shaped curve, standard distribution, but the top 3% are not always the people. I mean, they might be some of our engineers, but sometimes top 3% can't think and reason as well as others. Just saying, so think about that. We gotta get more math understandings. Appropriate tools strategically, that's choose and use. That's been abbreviated, and I really need to fix that slide because it's not just use them appropriately, it's you have to make choices about what you need. Because that's the other thing we found with kids that they don't know how to do. And that's even high school kids. They don't know which thing they need to use to figure this out. They gotta choose it. Attend to precision, it has to be right, come on, it's math. Look for and use of structure. Think about it, there are structures that you can see throughout these progressions. And when I say structure, I'm also talking within problems. If you see one structure beginning to work for you, then can you apply it to another situation? And then look in expressing regularity and repeated reasoning. Because there are certain paths we go down that we've been using repeated reasoning for a long time. And what I mean by repeated reasoning is if I do this, you know, when you're looking at an algebraic equation, can I apply it again to this situation as well? All right, again, and I'm not gonna, you can look at this, you're gonna have this, but again, there's that progression and you can see what we're doing and how we're getting to algebra. I kind of talked about focus and coherence, I'm not gonna go deeply into that anymore. Repetitive reasoning. All right, what I did want to do, and usually there's another person that comes with me, or when I say usually, one time. Rebecca is our high school person. And what I asked her to do, and I'm going to kind of go over this a little bit for you because this is specific to you with what you're going to be doing this summer, is when, this is our struggle for our math teachers right now. And I want to show you what you're going to be facing. This is, oh, did I just do that?
I think she had it set last time on like automatically.
Automatic.
Oh, that's right.
It said, I remember this from last time.
Yeah, it drove me nuts. See, we blended our two presentations, and I'm like,
She has
okay.
a transition built in or something.
Yeah, she does. So if you see me playing with this, or let me know, please. All right, lesson writing. They're trying to find out resources for the Common Core and do lessons. They're very, there's no textbook, there's no vendor that works, so now they're trying to put lessons together. And some of them are having issues being creative with this. Higher level questioning. The kinds of questions you ask are critical. It did it.
It's going quick.
Okay, drives me nuts. I don't know how she can speak that fast. Conceptual understanding, knowing the difference between understanding what is a step and what comes next, which is one piece of it, but that's not the deepest conceptual understanding. It's really understanding the depth of the concept. A lot of times, just because you know the next step, that doesn't necessarily mean you get it all. All right, yay. All right, here's some typical questions that a high school teacher might do now. You know, what is the volume cylinder with a radius 5 inches and a height of 10 inches? Typical answer in dialogue. Teacher, what do you do first? Ask, student, write down the formula. Then what? Plug in the numbers. Why'd you put the numbers there? Because the 5 is the radius, the 10 is the height. Okay, that's a nice, cute, little, neat little package. That's not conceptual understanding. Why did you use those numbers? Why did you do that step? Why is that the correct answer? And why is that the formula to use? None of this really gets, they're good questions in terms of why, but unless a kid really is able to explain this well, not going to get there. It's how you set up the question. Here's a different question. Given a cylinder with a radius of 5 inches, a height of 10 inches, and a cone having the same radius and height, how much larger is the cone? Show how you can prove this in 3 different ways. Now that's what I like to see. That's what the writers of the core want to see, and that's what our kids need to be able to do. Did it. All right, so the examples real quick. I think you started to see it already. You know, some use the formula, jump to that, nice, and gave their answer about 3 times larger, which we all know. Then using the formulas again, talked about 1/3, put it into fractions, again they get to that other place. And then they design an experiment at the cone of the cylinder and show how you can fill the cone 3 times. All right? I mean fill the cylinder 3 times with the cone. Ba-boom. Nice. Yes.
Are those the 3 proofs that they're asking for?
That's 3 approaches that a kid came up with.
Okay.
3 possible approaches. Could there be more? I hope it's infinite.
Well,
Yeah.
but the question was, like, prove this in 3 different ways.
Yes, and that's how they proved it.
Design 3 different ways to prove it.
Right. And well, they did it. I mean, they actually had to do it. And then added to that proof.
But this is really, ensure that that student is truly learning.
Yeah.
If they will be giving a more complex thing, they will be able to apply this knowledge rather than plugging in the formula.
And teachers for many, many years have simply looked at this one real quickly and said, when they asked all those why questions and they gave this answer, they thought that's deep. That shows me a kid knows how to do this. No, it doesn't. For one thing, they've been working on this for a week maybe, and that kid's got that formula in short-term memory, and here we go. Now, I'm going to go take the placement test for UC, and that's one of the questions I miss, because I don't know how to do this. And that's another thing. I'm not real big on formulas. Don't get me wrong, every single child should know how to get to that formula. But I get really irritated when I see teachers throwing out formulas and saying this is how you do it. Even calculus and derivatives and integrals, they better know how to get there. And they better understand what it means. They better understand the area under the curve. I mean, really? Do you not, you have to know why you're doing it and why it's useful. Kids don't know that. Go ahead.
No, go ahead. I was just going to say, I was going to share an analogy I heard about Common Core math I thought was really interesting. I can relate to it. It was kind of what you're talking about with the conceptual understanding. You said it's like when you use your GPS to figure out how to go somewhere, which is what I do when I'm actually challenged. And like you'll plug the address in your GPS and you just want it to turn right, you turn right, but you're not paying any attention to the streets. You don't know where anything is, and so then the next time you have to find that place, guess what? You got to use your GPS again because you didn't pay attention. Whereas if you had to go through the steps, you might have gotten lost, but you understood the neighborhood, and you could make a detour, and you could do it all, and you'd be confident. I'm like, yeah, I do it all the time. So
That's a beautiful analogy for formulas. And that's one of the reasons why we don't want teachers teaching formula-only algorithms. We want kids to get there. We want them to create them, just like we want them to get there and learn it. And I'm going to give you another example along with yours, and that is Cincinnati Public. Okay, I've been in Cincinnati since 1966. Okay, but downtown and the whole surrounding area, I don't know it all. I think I do, but I don't. And when there's detours and stuff like that, your GPS sends you in very weird locations.
yes, they do.
And all of a sudden, I'm realizing I could have done this. And I've done some experiments because I'm like that. I get real challenged things a lot. I bet you couldn't tell that about me. But I don't like things that are messy. So from my house, it tells me like 3 different ways to get down here to work. So what did I do? Because I was curious, I took all 3 ways and I timed them all at similar times. And I do that a lot because I get bored easy, right? So that GPS was wrong, of course, 2/3 of the time. There is one really fast way to get here except for traffic. And the thing that I didn't learn was what are all the different little routes that I could go to. We were a mess yesterday. I don't know if you all remember yesterday, but the semis blew up with each other and whatnot. And one of my friends said, Sheila, because I'm coming down 71 going, why is 71 such a hot mess? And one of my friends said to me, our director of testing, he said, Sheila, I just took Reading Road all the way in. Nobody thought to do that. I'm like, I mean, what was I thinking? That's just nuts. So again, was I a critical thinker at that moment? No, I was a little bit of a formula girl. Ugh. All right. That's the math at a glance. What I'm going to share with you a little bit, and I have a funny slide on here you're going to see in a minute, because I didn't change it. We do have the new standards out for science, but there's some similarities you're going to see with science. And the thing that I love about the science approach is everything that they're doing with science is inquiry related. And when I say inquiry, not just the word inquiry, because that sounds like an old buzzword, but it's true looking at something and saying, here's a problem. Here's a real world thing or a real world understanding I've got to have. How am I going to go about fixing it, solving it, finding solutions for it, or even beginning to understand it? Where do I go from there? And there's teachers, along with students, have to align and figure out ways of creating experiments and understandings, and then looking at the data that they're collecting, or the information, the qualitative, quantitative information that they're gathering, and putting it together and coming up with some assumptions. Could be right, could be wrong. And then going back to the drawing board if they have to. Well, the thing is, math is getting closer to this model than ever before, and if you think about it, the two are so completely linked. Again, it's the only way to do it. So, the next generation, here's some resources, and I've given you that if you ever want to look it up. All these things can be Googled, and again, those are in your notes. I hope you can read them. I did email Whitney, thank you. I emailed so many people, 100 emails.
I just-
Okay, so I emailed Whitney this PowerPoint, so if you ever want to look up some of this for the summer work, feel free. But again, these are pieces where the framework has come for the new science standards. These just got released. The state of Ohio is moving heaven and earth to get these adopted very quickly. I was at the math and science meeting last year. I still think we're a good year out from it. But people are already writing the curriculums towards it, just so you know, including Cincinnati. All right, there's the framework. So again, if you need to download it for free, there you go. It has 3 dimensions to it. Those 3 dimensions are scientific and engineering practices. How do I do this, and what are basic good scientific practices? Cross-cutting concepts. What are the pieces that are linked? Oh, I'm seeing some coherence here. And disciplinary core ideas, which are much like our practices. All right, here we go for the practices, just like math, which I love. Asking questions and defining problems. That's key. And to be honest with you, it kind of goes along with our critiquing and making arguments, but I wish that we said it this way. Developing and using models, okay, we had that in math. Planning and carrying out investigations. Obviously, you've got to prove your work, show your work. Analyzing and interpreting data, so important, you know that. Using mathematics and computational thinking, there we are, we're linked. Constructing explanations, here we go, just like math. Engaging in argument from evidence, because you've got to prove your point and you're not always completely right. We keep learning, I mean, again, this is where, I forget who was talking about nanotechnology, but she fascinated me the other day with some of the new learnings that we're learning. What color is gold? I know everybody sitting here probably knows all this, right? You know, what color is gold? Oh, really? You're nanotechnology, aren't you? Love it. I stumped him. Depends on how you slice it. You know, the thinner you get with the particles, and you're able to see more dimensions, so to speak. I don't know if I'm saying this correctly scientifically.
Yeah.
It's a different color.
The more
Maybe should I
nano
leave-
you go,
The more nano. Should I let him find out what color it is?
in fact, there's a teacher developed a red lesson.
I'll go
That's
with
a-
Just a right lesson on that? One of my
The students were
challenges.
shocked that it's not gold.
Exactly. I was shocked. When she showed us, I was like, really? So here's one of my challenges to you. Find out what color gold is. The more nano you get. I was really surprised, and understand that.
They were making solar cells and they were using spinach. And
Well-
they said, can that be used to produce gold?
I know, I was amazed. And the fact is that we can make it so nano to shoot it into our bloodstream and put it near a tumor and then heat it up. Not to a point that it hurts you or harms you, but that it kills the tumor. And they're doing these studies right now with mice. We're still 20 years out from FDA approval. But oh my God, we could have a really intense answer to cancer. I do believe, I pray that in 20 years we're
Drug
going to eradicate
delivery is a huge.
Yes. And then there was another nano piece that's going to have a lot to do with computers. The problem is they're going to have to redesign everything. So there's some issues, and you know this politically, but with nanotechnology, and I can't help it by digressing, this stuff just fascinates me, I'm so sorry. But the more nano you get, the more you slice it and you make it in thin layers. We're talking about how we're going to build processors in the future that are highly conductive out of carbon. We can't handle that right now. If we speed up our computers to 100 times, 1,000 times faster than what we do now, we've got to create new software, new hardware, So that's why it's taking time. We have the technology to do it right now with the nano. But now we've got to have some technology to go with it. And that's going to take time, because forget all this stuff. It's all going to look different. And I'm just like, oh, God love it. It's a great time to be, but once again, this is where we got to get our kids. We got to get our kids passionate and excited about it. We got to get them going, okay, I can start figuring some of this stuff out because I might be the person to create the next processor. Bill Gates said it the best in one of the things that I saw him at, one of the conferences that he was there, and he talked about, we do not right now have the technology to make the next really big leap that we need to make, because he's already beyond the nano because he knows it exists. But when we get to the next piece, what's it going to look like? And I'm not talking quantum, I'm talking what is it really, he goes, it's these brains out here, but you have to be critical thinkers. Nobody's going to feed you this. So here we go. Okay, I can't help it, I get all excited about that. All right, so, and then obtaining and evaluating, communicating information. This communication piece is really important. Being able to understand it and make good evaluations and just getting it is very important. You have to have that first, but you have to be able to communicate. So again, you're starting to see some of the literacy and language arts pieces coming through in science and math. If you can't talk about, explain, or show your reasoning, how can you go to college? How can you work in teams? Think about our world today. All of us work in teams now. Very few people work quietly by themselves in isolation forever. Few do, I'm not saying they don't, but even then, they got to communicate their ideas and their products to get them sold. All right, here are the main precepts, which are the cross-cutting pieces that tie everything together. Obviously, patterns in science. That's huge. We've got to be able to see what they are. Cause and effect, mechanism and explanation. And I'm not as familiar with all this, so I'm just going to kind of let you see what they are, but you can see how they go together. Scale, proportion, and quantity is being understood throughout. Systems and system models. Energy and matter, how does that work together? What are the flows? What are the cycles? What about conservation? And then structure and function. Again, I start seeing math. Every time I see structure and function, I start seeing math. Stability and change, math. What is decay? How do we compute that? You know, why is it even happening? All right, so here's what we're doing. We have our main core, and I will tell you some things that may be changing at CPS. Some discussions we're having maybe in the state of Ohio, maybe in the country. There are schools right now that are offering physics in 9th grade.
Oh, really?
And the reason they're doing that is because algebra goes with physics.
Okay.
If you think about it, a lot of physics, algebra and geometry go hand in hand with physics. You've got to have those two together. And there's a lot of thinking right now in education that if we put physics, now we're not doing it yet, we're talking about it, we're discussing it, but other schools are, so we're very much thinking about it. It's being suggested. But if we put physics first, because right now we do biology, biology pulls it all together. It's life science, but you have to have basic understandings about everything with biology, including chemistry. So if we do physics and chemistry first and we upload that, they go hand in hand. We are also creating new possibilities for AP courses. Because if our kids have what we do now, which is, when I say physical sciences and physics are very different. Now don't get me wrong, here's the Common Core, right? That's K-12. We're starting to think that this physical piece belongs in K-12, not physics, but physical sciences such as, you know, I'm studying stars, I'm studying matter, the core of the earth, those kinds of things. That's elementary. Now we're starting to say that we've got to get more physics right away so we can offer more AP later on. And we can get kids thinking about these things earlier because they should have the basic foundation at the elementary school for science. Obviously, some of the life sciences are at the elementary as well, but when we get into life sciences up at our level, now we're talking biology and we're talking some of the other microbiology and other courses that can be offered. Earth and space sciences, again, we're thinking they belong in the younger grade levels until it starts transversing into physics. And then some of the physics understandings taught in physics at the high school level. Engineering, technology, and applications of science are woven in 100%. Because if we don't have them woven in with the core discipline, none of this works. It's how do we do it? Did I just push that? I sure did. All right, here's the questions that teachers are asking. How do they embed it? Teachers still don't understand what engineering is. So they think these are two different topics. They don't understand that they're already doing it when they're trying to figure something out. How do I teach engineering to students on all levels? Okay, how do I teach kids how to figure stuff out? Yeah. See, I don't know why, but to me it seems very simplistic. But then again, when you try to break it down and understand that, which is what you're going to be doing this summer, you're going to be taking the math pieces and working with your teachers to help them design cool projects that will help their kids or help them lead their kids to a place where they can design cool projects, how does that fit in? How are they able to understand the understandings that go with engineering in terms of the practices and being able to figure things out and be able to come up with some ideas and solutions? How to even ask that first initial question. How do they do that? So you've got to help them with that. And where do I find resources that fit into my curriculum with my standards? Teachers are going to ask you that this summer too. So just be kind of aware of that. And resources are everywhere. And the biggest thing we can do for teachers, and I know that that's a lot of what I do, is help them find resources and teach them that, especially in this day of the computer, that resources are all around us, and I don't have to just give you one, and that's the gospel truth. Because teachers still want the science textbook. And I'm like, really? Really? You think I can contain all that in a textbook? Lord. So how do I find resources? And how are the resources related to what I'm doing? Because really, to be honest with you, when we're learning, we just need the resources that are specific to what we're doing. Because that's how we keep it and we understand it. You know, they don't need, here's all this stuff thrown at you. They need, okay, here's my question, here's my understandings. Where do I start to look for some answers? Again, that inquiry approach. Start finding the information, the understandings, which leads to another question, which leads to another question, which leads to another question. So how, and teaching teachers that that's how we do it, and that I'm not going to hand you a textbook, or you're not going to hand them all the answers, good luck with that. Because that's one of the things that we had issues with. And I think that was kind of it.
Yeah. Thank you.
So that's kind of what I leave you with. Real quick, I said that I would talk a little bit about literacy. Again, Rebecca was just my colleague who is one of our coaches, and that's my information. If you ever need to email me, please feel free. I do normally get back when unless it's like the 2 weeks that school's ending, or the 2 weeks that school's starting,
Yeah.
or if I'm out of town. So, but I do like answering questions if I have the answers. But one thing I do want to say about literacy is there's some major shifts in literacy, but the two that you could come away with that'll make it easy for you is the biggest problem we have with college. What do you think the biggest problem with English language arts is in college?
Critical reading.
Critical reading. Why do you think that is?
Because people read to get it done, not to understand it. Or they don't have the knowledge capable, or the background knowledge to understand what they're reading, like the technical knowledge to understand what they're reading.
Interesting. What do you mean by technical knowledge?
Well, I mean, if I guess that's more for engineering, math, sciences stuff, but if you're reading a paper, if you're reading a textbook or something, you don't have the technical knowledge to understand the background for it, then you're not really critically reading, you're reading words, but they mean nothing to you.
I would agree. I would agree with a twist. I'm going to explain that twist in a minute. What would be the other piece of English language arts that students have trouble with when they go to college?
Vocabulary.
Vocabulary is true. Vocabulary is for everybody, but vocabulary can be learned. Vocabulary can be learned. That is true, but that's not what we did. It is one of the 3 top things, though. But of the 2 top things, it's how do they express themselves and how do they feed it back out. And the only reason I'm jumping to that is that I'm going to keep you all day. I've already kept you, or I'm getting close, or I'm over. So just real quick, the biggest shift is, you're right, the biggest thing is, in elementary school, we teach our kids fairy tales and fiction and all kinds of stuff like that. That has meaning to them. They get it, you're right. They can get it because it has meaning to them, but we don't teach them how to attack and critically read non-fictional pieces. Pieces that they might even consider as boring. For example, have you ever sat down and really read the Constitution of the United States? If you ever read it, and that is an exercise we do, if you ever read it, and you sat down and read it, we take certain words, and there's one word, now I can't remember what it is, because I haven't done this in a while, but there's one word that gets repeated like 5 times. And we ask the kids to read it, which you know they're going, and then we say, okay, look for this word. Oh, And now they gotta look for the word. And they do a variety of approaches, some skim, some ask their neighbor, some read again. Then we say, okay, what did we mean by this word in this sentence? How was it used this way? Okay, and I'm just giving you one approach. But what I'm saying is, as you follow that word, and I don't think it's respect, but it might be. I can't remember the word now. But there's places in the Constitution that it's used differently. It starts to tag you into the words around it. And then you start saying, they meant this. When I did that exercise, you know, and I did government, I mean, I got 2 masters. I mean, I consider myself educated, smart, humble. But I learned things about the Constitution I had no idea. And then all of a sudden I'm like, really? So the point is, our kids don't know how to do critical reading, like you said, of nonfiction text. So when they get a textbook, physics, engineering, whatever, they don't know how to take that apart. There are literal processes that kids, any human being has to go through when they try to make sense. And believe it or not, as you do that, I mean, I have high-end magazines in my home because I don't do people and all that stuff. I know my daughter does all that. She just drives me nuts. But, you know, I like reading the critical pieces and going through it because I've been practicing and doing it for a long time. So the big thing with language arts is nonfiction at younger grades. And the percentages vary. We don't throw them into nonfiction right away. We say, I forget what it is, maybe 75%, 25% kindergarten. You know, it's fiction, feel-good stuff, and then that. And then it goes up and up and up and up till in high school you're reading pretty much nonfiction unless you're in a literature class, reading the classics or whatever. Okay? Why? Because they had to be college and career ready. Because our kids were opening textbooks at the college level and going, oh no, I don't. And they couldn't understand it. All right, the second thing we're doing is we are making sure that teachers are asking questions that are text dependent. It used to be, oh, let me tell you the whole background about this, and let me tell you everything, whether it's fiction or nonfiction, you know, let me tell you all about what I know about butterflies. And then we're going to go read a nonfiction piece on butterflies. No. Now we're talking a cold read. Because what do you do when you get to college? You do a cold read. Your professor says, read 6 chapters by such and such time, and then we're going to go over it. I'm going to give you a test on it. I mean, it just depends on professors, obviously, but expectations are that you can do these things. So our kids now have to read something and then go back and find what we call text-dependent questions, evidence within the text to support an answer to a question. It's not a, how did you feel about the story? We've nixed that. Teachers love, I just had a teacher the other day, we were talking about this. I just happened to be on the end of the conversation. It wasn't really my conversation because it was ELA. But they were sitting there and they were talking about, I went into a classroom and a teacher was asking how you felt about this, how you felt about that. I'm not saying there isn't a place, sociology or whatever, you know, maybe some one-on-one discussion because a kid's got a problem that you talk about how you feel. But in the real world, how you feel is not really what matters in terms of you understanding something. You've got to be able to give me evidence. Everything we do in life, give the evidence. So now in reading, you've got to give evidence. So that's the second change. And the third change is vocabulary. Making sure that at grade levels, the lexiles, which is the way the strength of the vocabulary, the complexity of a text, that the lexiles are high enough that we're challenging kids and we're focusing on something we call tier 2 words. But what that means is we're not talking about just the dolch words, the, was, and then some of your heavy duty vocabulary that are specific to a topic. But we're talking about higher level understanding words that kids have got to be better at so that it comes easier to them when they read. So that when they do read, they can make sense of the vocabulary that is the deep contextual words relating to engineering or whatever you may have, depending on what you're reading, and they can make sense of it from the words around it. So, and they learn how to build their own vocabulary. So those are the 3 biggest changes. Don't get me wrong, a lot of the ELA stuff is still the same, except for those 3 big changes. We want to make sure that vocabulary is huge. We want to make sure that text-dependent questions are there, and we want to make sure that we're doing a lot of nonfiction. A lot of nonfiction.
You know, when in my literature class during my school days, our literature teachers, and we used to be examined on, one question used to be, which used to be called as a reference to context question. Like we read Shakespeare, for example. A quote
Now,
will
that's
be
a good one to
given,
be able to do that.
okay, a quote. Then what we have to answer, first of all, you have to, so that you know, you have to say who said it, when said it. But then you go further, what are your reasoning that why this person said this? What made them say this?
Exactly.
Okay.
And I think in literature, there's a place for that when you're really trying to delve into the purpose of the author, or to, because a lot of times it was socioeconomic concerns of the present day.
So you diverging to all those types
Right,
of
and
things.
I think all those have a place, and they're still in the standards.
Yes.
But what we still do too much at the younger grade levels, which is really sad, is we ask them all the time how they feel about this, or we begin a lesson with a whole lot of background knowledge, which we thought we were doing the right thing because we were setting the context. Don't get me wrong, we thought that was the way to approach teaching, and it made it easier and more accessible for kids to read. It did. But the problem with that, we had a terrible situation. We created a bad situation for the future by doing that, because kids got too used to this feel-good type of approach rather than being able to say, hey, I can just sit down and read this. They felt like they always needed help, or they needed somebody to get into the story before they did and lead them along the way. And let's face it, by the time you get into high school, and especially by the time you get into college, you can't do that. You've got to be able to attack a text, whether it's a book, whether it's an article, and you've got to be able to take it apart, try to make meaning out of it, and then try to apply it. And our kids, they couldn't do that. And even in Shakespeare,
Yeah.
that may not be fiction. I mean, that may not be nonfiction.
Yeah.
But
You know,
there's plenty of complexity there.
complex. And one other thing then we have to ask is, what does it, what the character said, what does it tell you about the character of that person itself?
And again, these are places that are really important in terms of literature, sociology, understanding our world around us as a social being. However, when it comes to making kids college and career ready, that's not what we're doing, because it's what we've done, and it's what we've done all along. We talked about Cinderella and the 3 bears, and I'm not saying there's no place for that. There is in the younger grades. But then they can't get to these complex texts. When you're asking, you give kids a story that engages them, and they're reading about it, and then they got to answer all these questions. They're answering a lot of questions without providing evidence. Well, then they get into science, and they got to provide evidence. How are they going to do that? Or you get, like you said, an electrical text, or a text on engineering or nanotechnology, or I forgot you said
Waste navigation.
there we go, oh my gosh. Fuels, all the things that you're doing, you're weeding through some text. I know. Now, it gets easier for you, you can weed through it easy now. And probably or at least easier. Part of the reason for that is because you've been practicing doing that over and over again. And that's basically what we're saying. In schools now, we're going to give them time to practice doing that a whole lot more, so that they have lots of practice with that. So by the time they get to college, this is not something they've got to learn right away. Because a lot of our kids drop out because they can't even pass English 9. Or they can't even, the first technical course they get, they can't do it. They can't write. They can't understand what they're reading. And then they listen to the lecture, it sounds foreign, they're done. So, you guys have a big job ahead of you this summer. Thank you for listening. I wasn't able to make this as interactive as I would have liked to, but I felt like you had to have, and I did this for the professors as well.
Yeah.
I did this because I felt like you had to have a firm understanding of where we've been, where we're going, so that you understand what we're trying to do really in high school and junior high right now. So and you need to understand too, some of our kids, so our teachers are going to be working on projects for you. The Common Core is new. So we have mixtures of the old and the new. So there's kids, teachers that are coming in going, my kids don't even know how to multiply. So these are some of the issues that they're going to be trying to figure out as they create the scenarios that they create, these big projects that they're doing, and they're trying to find ways to engineer their way through. They've got some real problems facing them. But at least now that you understand where we're going, what we've been doing, you can really help them as they say other things to you like, how do I attach this to my standards? Because I did hear that last year from teachers that went through the program. They said, this is all good and well, but I've got state tests to take. I've got to be able to attach this to the standards. Well, you've got them. You have the standards. And they are right about that, but the other thing you need to understand is, especially from 8th grade up, they're doing algebra. So the math piece, you should be able to attach very easily. The science piece is going to be specific to what science they're going to be doing that year. So there may be some limitations for them when they try things out in their classes. There's also some things too where we know that we're giving them some leeway. Like I've told some of the teachers, I said, you know, if you're creating a project that has nothing to do with it, we're going to understand that piece. You just got to make sure that you still get in your pieces that you need to get in so that your kids can pass their tests when they need to take them. Because they have semester exams and exams, you know. So, if I can ever help you in any way, let me know. You guys have been you've sat for a long time. You've been awesome. That's amazing because I can't even do that. So thank you.
so much, Sheila. We
All right.
appreciate it. Thank you very much.